All right, so in this video, we're going to pick up back where we were with our single visualizations of a single numerical variable. And now we're going to start thinking about how can we add on extra variables into that plot. So this is things like, how do we add a categorical variable into this visualization of the distribution of a numerical variable, as well as how can I visualize the relationship between two numerical variables. So the first piece is we can think about, if I were to have had my box plot before, where I had the distribution of the bill lengths, how can I separate those based off of the species of the penguin? So this is something like where I have this bill length that I had before, but now I want to separate based off of species. So we see that this code looks almost the same as what we had before. The box plot is still there. The only thing that we've added is we now have one variable that's being labeled as the y variable and one variable that's being labeled as the x variable, where we only had one variable there before. So when I run this, I see that my bill length is associated with my y-axis, which makes sense because it's my y variable. My species is associated with my x-axis, so I get these sorts of side-by-side box plots. If I instead wanted them to be stacked vertically, I could have switched this so that my x variable was my bill length and my y variable was my species. And this would give me just a slightly different orientation where each of these box plots is now stacked vertically instead of horizontally. So we see that each of these box plots looks similar to what we had before, where we have those same numerical summaries with our quartiles and our min and our max, but we do start to see that there are these data points that are flagged as outliers that are then plotted as individual points that can give us room for us to investigate, well, what is this outlier and should we keep it on our data set or does it deserve further investigation? So this sort of layout looks fairly similar to what we see from this idea of a ridge plot, which is inspired by similar profiles to like mountain ranges, where we're looking at these different silhouettes of these mountain ranges. So unfortunately, the density ridges doesn't live inside of the ggplot, the tidyverse package. So what we need is we need to load in the ggridges package. So I'll go ahead and load that in. And then once I run this, so we'll notice here that all I've changed is I've changed from a box plot to a density ridge. So this is a similar idea to having side-by-side density plots, and they're going to be stacked vertically. So we're thinking about having these vertical stacks, so it's going to look fairly similar to what we see here. So let's go ahead and run this code. So we see similar to what we had before, where each of our species is on our y-axis. Our bill length is on our x-axis, but instead of having those sorts of box plots here, now we see these density plots. So these are our side-by-side or our stacked density plots, where you're able to see essentially the shape of the distribution of each of these species for the bill length. If you were to, which we see here, that if we wanted to make sure that we could try and see behind each of these plots, we can lighten them a little bit using an alpha argument. So I could change my alpha to say something like 0.5, because 1 is the default and 0 is completely transparent. So something in the middle maybe would work well for us. So if I look at this, well, now I can see behind this distribution of Adele penguins and see those sorts of chin strap penguins and see what that left tail looks like. So that's a good tool for us to have in our tool bag. Finally, if we were to, instead of plotting a categorical variable on our y-axis, we could instead think about two numerical variables. And this is something like a scatter plot, where instead of having a categorical variable here, now we have two numerical variables. We're plotting the relationship between the bill length of the penguins and the bill depth of the penguins. But we notice that there is a slight difference in the geom that we're using. We're moving from a box plot, a density plot, to now here we're using a geom point. This is something like what you saw before in your first tutorial, where we're thinking about how are we geometrically representing each of the observations in our data set, and we're plotting it as a point, specifically as an ordered pair on an XY grid, where each penguin's bill length and bill depth is marked by a point. So if I were to run this line, then we see this sort of scatter plot of all of the points of the relationship between the bill depth and the bill length. So these are all of the different ways in which we could plot to the relationship between two variables, whether they're numerical or whether they are categorical. These are the relationships that we have. As long as one of our variables is numerical or continuous, then these are all of the options that we have. All right, so we'll move on to 3 or more variables, and that'll be it.